Hello, and welcome back to Calero Academy's Part 2 of the problem from the book Introduction to Mathematical Statistics by Robert V. Hogg and Alan T. Craig. If you watched Part 1, you'll remember that we ended off with the left-hand side is equal to the 2 times the integral from b to m of x f of x dx minus b plus 2b cap f of b. Now, I promised you in the last video that I would give you a really surprising trick to help you get to the final solution. And here it is. So, first let's figure out what b to m, the integral from b to m of b f of x dx is. It was really neat. I was messing around. I got into this end product, and I didn't know what to do with it. It was just, what could I do? I'd gotten so close, but nothing could be done. What you have to realize, I had to mess around a little bit with some other integrals, and notice that this integral is equal to b outside of the distribution function from b to m, which is equal to b outside of f of m minus b of f of b, which is equal to b on 2, because remember last lesson I taught you, from the distribution function from minus infinity to the m, the median, must equal to a half, because the distribution function is split perfectly in half by the median m. So it's equal to b on 2 minus b cap f of b. Notice anything similar between this expression and this expression? Notice anything? Look. Multiply this by 2. So we have 2 integral from b to m of b f of x dx is equal to b minus 2b cap f of b. Getting warmer, isn't it? Notice anything similar now? You should probably notice by now that the only difference between this expression and this expression is that this one is the minus 1 times this expression. Now we've got our trick. Let's substitute this integral minus this integral into here. So we have left-hand side is equal to 2 times the integral from b to m of x f of x dx minus 2 of the integral times the integral from b to m of b f of x dx. This is equal to, since we're integrating from the same limits, what we do here, we have 2 outside of the integral b to m of x fx dx. No, sorry, don't say the dx, sorry about that. So we have the left-hand side is equal to 2 of the integral from b to m of x fx dx minus b fx, all times dx. So, let's take the fx out of this expression here. And we have the left-hand side is equal to 2 times the integral from b to m of f of x times x minus b. Remember, the thing on the right-hand side, which we want to get to, is equal to 2. Right-hand side is equal to 2 integral from b to m. Sorry, is equal to the 2 times the integral from m to b. Sorry about that. Of b minus x fx dx. Now, we just manipulate this integral here. Let's switch to get to the m to b, let's switch the order of integration. We have, the left-hand side is equal to 2 times the integral. Okay, minus 1 times 2 times the integral from m to b of fx, x minus b, dx. Now, where should we put that minus 1? Conveniently, we have x minus b here, and b minus x, and minus 1 times x minus b is equal to, ta-da, the 2 times the integral from m to b of b minus x, just switching the order of multiplication, b minus x times f of x times dx. And this is equal to the right-hand side. Therefore, we have just proven that the expectation of the absolute value of cap x minus b is equal to the expectation of the absolute value of cap x minus m plus 2 times the integral from m to b of b minus x in brackets times fx dx. This